हेलो एवरीवन, वेलकम टू द लाइव सेशन। तो आज हम देखेंगे एनसीईआरटी ज्योग्राफी क्लास 11 का यूनिट 5 वाटर ओशंस। इसमें हम देखेंगे चैप्टर 13 वाटर, जिसमें कि हम देखेंगे ओशंस। तो शुरू करते हैं। कैन वी थिंक ऑफ लाइफ विदाउट वाटर? इट इज सेड दैट द वाटर इज लाइफ। वाटर इज एन essential component of all life forms that exist over the surface of the earth. The creatures on the earth are lucky that it is a water planet. Otherwise, we all would have no existence. Water is a rare commodity in our solar system. There is no water on the sun or anywhere else in the solar system. The earth fortunately has an abundant supply of water on its surface, hence our planet is called the blue planet. Hydrological cycle. Water is a cyclic resource. It can be used and reused. Water also undergoes a cycle from the ocean to land and land to ocean. The hydrological cycle describes the movement of water on, in, and above the earth. The water cycle has been working for billions of years, and all life on earth depends on it. Next to air, water is the most important element required for the existence of life on earth. The distribution of water on earth is quite uneven. Many locations have plenty of water while others have very limited quantity. The hydrological cycle is the circulation of water within the earth's hydrosphere in different forms. That means the liquid, solid and the gaseous phases. It also refers to the continuous exchange of water between the ocean, atmosphere, land surface and subsurface and the organism. About 71% of the planetary water is found in the oceans. The remaining is held as fresh water in glaciers and ice caps, groundwater sources, lakes, soil moisture, atmosphere streams, and within life. Nearly 59% of water that falls on land returns to the atmosphere through evaporation from over the ocean as well as from other places. The remainder runs off the surface, infiltrates into the ground, or a part of it becomes glacier. It is to be noted that the renewable water on the earth is constant while the demand is increasing tremendously. This leads to water crisis in different parts of the world, spatially and temporally. The pollution of river waters has further aggravated the crisis. How can you intervene in improving the water quality and augmenting the available quantity of water? Relief of the ocean floor. The oceans are confined to the great depressions of Earth's outer layer. In this section, we shall see the nature of the ocean basins of the Earth and their topography. The oceans, unlike the continent, merge so naturally into one another that it is hard to demarcate them. The geographers have divided the oceanic part of the earth into 5 oceans, namely the Pacific, the Atlantic, the Indian, Southern Ocean, and the Arctic. The various seas, bays, gulfs, and other inlets are part of these 4 large oceans. A major portion of ocean floor is found between 3 to 6 kilometers below the sea level. The land under the water of the ocean, that is the ocean floor, exhibit complex and varied features as those observed over the land. The floors of the oceans are rugged with the world's largest mountain ranges, deepest trenches, and the largest plains. These features are formed like those of the continents by factors of tectonic, volcanic, and depositional processes. Divisions of the ocean floors. The ocean floors can be divided into 4 major divisions: the continental shelf, the continental slope, the deep sea plain, the oceanic deeps. Beside these divisions, there are also major and minor relief features in the ocean floors like ridges, hills, sea mounds, gorges, trenches, canyons, etc. Continental shelf. The continental shelf is extended margin of each continent occupied by relatively shallow seas and gulfs. It is the shallowest part of the ocean, showing an average gradient of 1 degree or even less. The shelf typically ends at very steep slope called the shelf break. The width of the continental shelf vary from one ocean to another. The average width of continental shelves is about 80 km. The shelves are almost absent or very narrow along some of the margins like the coast of Chile, the west coast of Sumatra, etc. On the contrary, the Siberian Shelf in the Arctic Ocean, the largest in the world, stretches to 1,500 km in width. The depth of the shelf also varies. It may be as shallow as 30 meters in some areas, while in some areas it is as deep as 600 meters. The continental shelves are covered with variable thickness of sediments brought down by rivers, glaciers, wind from the land and distributed by waves and currents. Massive sedimentary deposits received over a long time by continental shelves becomes the source of fossil fuels. Continental slope. The continental slope connects to the continental shelf and the ocean basins. It begins where the bottom of the continental shelf sharply drops up into a steep slope. The gradient of the slope region varies between 2 to 5 degrees. The depth of the slope region varies between 200 and 3000 meters. The slope boundary indicates the end of continents. Canyons and trenches are observed in this region. Deep sea plain. Deep sea plains are gently sloping areas of the ocean basins. These are the flattest and smoothest regions of the world. The depths vary between 3000 to and 6000 meters. These plains are covered with fine-grained sediments like clay and silt. Oceanic deeps or trenches. These areas are the deepest parts of the oceans. The trenches are relatively steep-sided narrow basins. They are some 3 to 5 km deeper than the surrounding ocean floor. They occur at the bases of continental slopes and along island arcs and are associated with the active volcanoes and strong earthquakes. That is why they are very significant in the study of plate movements. As many as 57 deeps have been explored so far, of which 32 are in the Pacific Ocean, 19 in the Atlantic Ocean, and 6 in the Indian Ocean. Minor relief features. Apart from the above mentioned major relief features of the oceanic floor, some minor but significant features predominate in different parts of the oceans. Mid-oceanic ridges. A mid-oceanic ridge is composed of two chains of mountains separated by a large depression. The mountain regions can have peaks as high as 2500 meters and some even reach above the ocean surface. Iceland, a part of the mid-Atlantic ridge, is an example. Seamount. It is a mountain with pointed summits rising from the sea floor that does not reach the surface of the ocean. Seamounts are volcanic in origin. These can be 3000 to 4500 meters tall. The Emperor Seamount, an extension of Hawaiian Island in the Pacific Ocean, is a good example. Submarine canyons. These are deep valleys, some comparable to the Grand Canyon of the Colorado River. They are sometimes found cutting across the continental shelves and slopes, often extending from the mouths of large rivers. The Hudson Canyon is the best known submarine canyon in the world. Fjords. It is a flat-topped seamount. They show evidence of gradual subsidence through stages to become flat-topped submerged mountains. It is estimated that more than 10,000 seamounts and fjords exist in the Pacific Ocean alone. Atoll. These are low islands found in the tropical ocean consisting of coral reefs surrounding a central depression. It may be a part of the sea or lagoon or sometimes form enclosing a body of fresh brackish or highly saline water. Temperature of ocean waters. This section deals with the spatial and vertical variations of temperature in various oceans. Ocean water gets heated up by solar energy just as land. The process of heating and cooling of the oceanic water is slower than land. Factor affecting Temperature distribution. The factors which affect the distribution of temperature of ocean water are latitude. The temperature of surface water decreases from the equator towards the poles because the amount of insulation decreases poleward. Unequal distribution of land and water. The oceans in the northern hemisphere receive more heat due to their contact with larger extent of land than the oceans in the southern hemisphere. Prevailing wind. The winds blowing from the land towards the ocean drive warm surface water away from the coast, resulting in the upwelling of cold water from below. It results into the longitudinal variation in the temperature. Contrary to this, the onshore winds pile up warm water near the coast and this raises the temperature. Ocean currents. Warm ocean currents raise the temperature in cold areas while the cold currents decrease the temperature in warm ocean areas. Gulf Stream or warm current raises the temperature near the eastern coast of North America and the west coast of Europe, while the Labrador current or cold current lowers the temperature near the northeast coast of North America. All these factors influence the temperature of the ocean currents locally. The enclosed seas in the low latitudes record relatively higher temperature than the open seas, whereas the enclosed seas in the high latitudes have lower temperature than the open seas. Horizontal and vertical distribution of temperature. The temperature depth profile for the ocean water shows how the temperature decreases with the increasing depth. The profile shows a boundary region between the surface water of the ocean and the deeper layers. The boundary usually begins around 100 to 400 meters below the sea surface and extends several hundreds of meters downward. This boundary region from where there is a rapid decrease of temperature is called the thermocline. About 90% of the total volume of water is found below the thermocline in the deep ocean. In this zone, temperatures approach 0 degrees Celsius. The temperature structure of oceans over middle and low latitudes can be described as a three-layer system from surface to the bottom. The first layer represents the top layer of warm oceanic water and is about 500 meters thick with temperatures ranging between 20 degree and 25 degrees Celsius. This layer within the tropical region is present throughout the year but in mid latitudes it develops only during summer. The second layer, called the thermocline layer, lies below the first layer and is characterized by rapid decrease in temperature with increasing depth. The thermocline is 500 to 1000 meter thick. The third layer is very cold and extends up to the deep ocean floor. In the Arctic and Antarctic circles, the surface water temperatures are close to 0 degrees Celsius and so the temperature change with the depth is very slight. Here only one layer of cold water exists which extends from surface to deep ocean floors. The average temperature of surface water of the ocean is about 27 degrees Celsius and it gradually decreases from the equator towards the poles. The rate of decrease of temperature with increasing latitude is generally 0.5 degrees Celsius per latitude. The average temperature is around 22 degree at 20 degree latitude, 14 degrees Celsius at 40 degree latitude and 0 degree Celsius near poles. The oceans in the northern hemisphere record relatively higher temperature than in the southern hemisphere. The highest temperature is not recorded at the equator but slightly towards north of it. The average annual temperature for the northern and southern hemisphere are around 19 degrees Celsius and 16 degrees Celsius respectively. This variation is due to the unequal distribution of land and water in the northern and southern hemisphere. Figure shows the spectral pattern of surface temperature of the ocean. It is well known fact that the maximum temperature of the ocean is always at the surfaces because they directly receive the heat from the sun and the heat is transmitted to the lower sections of the ocean through the process of convection. It results into decrease of temperature with the increasing depth, but the rate of decrease is not uniform throughout. The temperature falls very rapidly up to the depth of 200 meter, and thereafter the rate of decrease of temperature is slowed down. Salinity of ocean water. All waters in nature, whether rainwater or ocean water, contain dissolved mineral salts. Salinity is the term used to define the total content of dissolved salts in seawater. It is calculated as the amount of salt in gram dissolved in 1000 gram or 1 kg of seawater. It is usually expressed as parts per thousand or ppt. Salinity is an important property of seawater. Salinity of 2.47 parts per thousand has been considered as the upper limit to demarcate brackish water. Factors affecting ocean salinity are mentioned below. The salinity of water in the surface layer of ocean depend mainly on the evaporation and precipitation. Surface salinity is greatly influenced in coastal regions by freshwater flow from rivers and in polar regions by the processes of freezing and thawing of ice. Wind also influences salinity of an area by transferring water to other areas. The ocean currents contribute to the salinity variation. Salinity, temperature, and density of water are interrelated. Hence, any change in the temperature or density influences the salinity of water in an area. High salinity in water bodies. Lake Van in Turkey 330 ppt, Red Sea 238, Great Salt Lake 220. Horizontal distribution of salinity. The salinity for normal open ocean ranges between 33 ppt and 37 ppt. In the landlocked Red Sea, it is as high as 41, while in the estuaries and Arctic, the salinity fluctuates from 0 to 35 seasonally. In hot and dry regions where evaporation is high, the salinity sometimes reaches 70. The salinity variation in the Pacific Ocean is mainly due to its shape and larger areal extent. Salinity decreases from 35 to 31 on the western parts of the northern hemisphere because of the influx of melted water from the Arctic region. In the same way, after 15 to 20 south, it decreases to 33. The average salinity of the Atlantic Ocean is around 36 ppt. The highest salinity is recorded between 50 and 20 latitudes. Maximum salinity 37 is observed between 20 north and 30 north and 20 west to 60 west. It gradually decreases toward the north. The North Sea, in spite of its location in the higher latitudes, records higher salinity due to more saline water brought by the North Atlantic drift. Baltic Sea records low salinity due to influx of river waters in large quantity. The Mediterranean Sea records higher salinity due to high evaporation. Salinity is, however, low, very low in Black Sea due to enormous freshwater influx by rivers. See the atlas to find out the rivers joining Black Sea. The average salinity of the Indian Ocean is 35. The low salinity trend is observed in the Bay of Bengal due to influx of river water. On the contrary, the Arabian Sea shows higher salinity due to high evaporation and low influx of fresh water. Figure shows the salinity of the world ocean. Vertical distribution of salinity. Salinity changes with depth, but the way it changes depends upon the location of the sea. Salinity at the surface increases by the loss of water to ice or evaporation or decreased by the input of fresh water. such as from the rivers. Salinity at depth is very much fixed because there is no way that water is lost or the salt is added. There is a marked difference in the salinity between the surface zone and the deep zones of the oceans. The lower salinity water rests above the high salinity dense water. Salinity generally increases with depth, and there is a distinct zone called the halocline where salinity increases sharply. Other factors being constant, increasing salinity of seawater causes its density to increase. High salinity seawater generally sinks below the lower salinity water. This leads to stratification by salinity. तो ये था आज का हमारा चैप्टर, ये इसका एक्सरसाइज है, आप चाहे तो ये कर सकते हैं। आज के लिए इतना ही। थैंक यू, थैंक्स फॉर ज्वाइनिंग।